Usually I like to try to post a blank page of these notes. For some odd reason, and I don't know why, this slideshow that I have, it's not letting me save my or post images, change it to a PDF and post the image. So I have a feeling that the notes that I take today are not going to be able to be posted, but that's why I'm going to do the video for today, just so we can make sure that we get this documented. All right, so what do we got? List the pair of congruent angles. Now, it's hard to tell from a picture, which is why we always want to read the statement. And angles are really quick. Angle T, if they're similar, the angles are congruent. So angle T has to be congruent to angle C. So I'm going to use my markings, and then we're just going to say angle T is congruent to angle C. And then we can go right down the list. H is the 90 degree, and that's O, so those are already marked. And then the last one, S, is congruent to L. And I should put markings on that. Okay, now that also helps me identify the side lengths. So here's how we would actually look for the scale factor. So notice it says set up the proportions of the sides. Well, a proportion is a ratio that equals a ratio. So what we're going to do is we're going to set up the side length TH. Now notice that's one marking to the 90 degrees. So this side length is proportionate. They're not congruent. They don't have to be congruent here because of the similarity. So we're just going to take TH over CO. So that's the two sides that correspond. And then I'm going to compare it to the other pair of corresponding sides, which I can say HS. Now HS is the 90 degree to the two markings, so that's OL, or in this case OL. And then that would also be equal to the other matching, which you can say S to T or T to S, it really doesn't matter. But whatever order I follow here, I should follow the same order here. So T to S matches with C to L. Now, how would you find the scale factor? You take your ratio of corresponding sides. That's what this is this is the proportion or the ratio of corresponding sides all matched up. So if I had some numbers, I'm just going to make this up. Let's say that this is, let's see, let's go 9, 12, 15. And then let's see, this is the small side, TH is the small side, and this is not drawn to scale, but so TH to CO. So I might call this 3 and 4, 5. All right, so let's say I gave you this picture and I asked you to find the scale factor. Well, what would you do? You would take the ratios of these sides. Now look at TH is the small one on this side. So I'm going to compare it to the small one on this side. So I'll say 9 over 3. And then what is HS? HS is 12 over OL. OL is 4. All right, and then TS is 15 over CL, which is 5. Now notice, those aren't identical, right? But they should be equal because this is similar. So I'm crossing my fingers that I made up the correct numbers in the right spot. But let's reduce. When you reduce a ratio of corresponding sides, so if I divide by 3 top and bottom, I get 3 over 1 here. If I reduce 12 over 4, I divide by 4 top and bottom, I get 3 over 1. And then 15 over 5, if I divide by 5, I get 3 over 1. So notice, those ratios are all the same. Well, what does that mean? That means my scale factor is 3 to 1, or you could write it as 3 over 1. Now, here's a great question. What if you flipped everything around? What if you compared the triangle, the small triangle to the big triangle. So what if you put all the small lengths in the numerator and all the bigger from the bigger triangle in the denominator? Then your scale factor would be flipped. It would be the reciprocal, it would be 1 to 3. And in this case, if they give you a statement, you always want to take from the first THS, this triangle should always go on top, and then COL should always go in the denominator. So that's how you find scale factor. And then if, let's say that I didn't know one of these sides, let's say that I didn't know that was 3. All right, how could I use the scale factor? So you didn't ask to do this, this is just an extension. Well, what would I do? If 9 over 3, well, I didn't know this was 3, let's say I called it x. So 9 over x, that has to equal the scale factor. And the scale factor is 3 to 1. And there's my ratio. 9 over x is equal to 3 over 1. Now we're going to cross multiply. And it's the act of solving proportions. So 9 times 1 is 9. 3 times x is 3. If I divide by 3, it confirms what we already knew, that that was 3. All right, so kind of a quick review of what we learned leading up to this point. You don't have to write this page down, but today we are doing section 6.4 and 6.5. And I want you to notice the directions, though. We're learning to prove that triangles are similar. So we are going to set up a 2-column proof today, and we're going to do a couple proofs by hand. The nice thing about similarity is there's only 3 methods for proving triangles are similar. Angle, angle, which is probably like the most friendly proof we're ever going to see. That's a really quick one. And then the other 2 deal with side lengths. So we have side, side, side similarity. And then we have side, angle, side. And notice that angle is in the middle of the 2 sides. So that is the included angle. And there is some, no pun intended, there is some similarity with how we approach proofs for proving triangles are similar to ones that we did when they were congruent. All right. So I'd like you to write this down. Angle-angle similarity postulate says if 2 angles in one triangle are congruent to 2 angles in a second triangle, then the triangles are similar. Now, some people just like to write the pictures, and that's up to you. I would include both the writing and the pictures here. So I'll give you a second to get caught up on that. So what does this postulate tell us? It says that if you can conclude when you have 2 triangles that you have 2 pairs of corresponding angles. So notice angle K is congruent to angle Y. And that either is given or somehow you prove that that is true. And then you've got angle J congruent to angle X. Then you have enough to prove that the triangles are similar. Because if the angles are congruent, the side lengths will have to be proportional. That's what this proof is saying. Now, the other question that I always get is, how come it's not angle, angle, angle? Why is it only 2 angles? Well, we had a theorem back in Unit 1 that said if you knew 2 angles of one triangle are congruent to 2 angles of the other, then you could automatically find the third angle. Angle L and angle Z have to be congruent because all 3 of these have to add up to 180. And if these 2 are the same, that means angle L has to be congruent to angle Z, which is really nice because then we only have to show 2 angles because that will always be the case. We don't ever have to show that third angle. All right. Um, I don't want you to write this. We've got a lot to write today. All I want you to do is kind of look at this and maybe in your head or just as like a side work, I'd like you to just answer this question right here. So we'll do the first one together and then I'll have you just kind of answer this one in your head. But determine if the triangles are similar and write a similarity statement and then find the scale factor. So we are going to still work on that scale factor. Um, but in the first problem, I hope you're looking at this as, well, determine they're similar. What do we know? I have one pair of corresponding congruent angles, and then I have another pair. So right away, you know that these triangles have to be similar by angle, angle. So then you're going to write your similarity statement. Well, which triangles are similar? Now here's the tricky part. We don't have um, we don't have congruent markings. I can't use congruent markings, so I have to read the angles. I can use colors. So what if I start at the 90-degree angle and I say angle E? Well, angle E has to match up with the other right angle, that's C. And then if I go from E to K, that's the other angle we know. Following this triangle, that would go C to D. So E to K matches C to D. And then if I follow K to Y, that's the order that I would follow in this triangle. So then I would go D to J. And you have to make sure you really are matching those carefully. So those triangles are similar by angle, angle similarity. All right. Now, because they're similar, now I want to find the scale factor, and I only know one side. And by the way, because I wrote EKY first, then that's the side I'm going to deal with first. So I'm going to look at the scale factor as the side length KE. Well, KE matches with DC. So then I know their values. I know KE is 36, and I know DE is 12. And then if I just divide it out, if I divide the top by 12 and the bottom by 12, I get 3 over 1. And notice, when we say scale factor, we want it as a ratio. I know this is equal to 3, but you want your ratio, you can write it as 3 over 1, or you can write it as 3 to 1. Okay. Now, if you started with the small one first and then went to the big one, then this would be reciprocated, it would be flipped around, so it would be 1/3. And because we didn't give you the direction, 1/3 would also be correct. All right, let's look at the next one real quick. Um, so, what do we know? Angle T matches with angle U. Angle H matches with M. I have angle, angle, so therefore, if this is true, these side lengths have to be proportional. So I'm going to write my congruent statement first, and let's start at T. And let's see, T is the one marked angle, so that means I would start at U. And then I went T to H. That's the two markings, so U to M. And then I'd go H to S, and then finish, and that would make the triangle. THS is the same as UMN. Tarleton High School is similar to the University of Minnesota. Okay, why are they similar? By angle, angle. And now I've got two pieces to choose from. And this is why I started with the statement. I'm not 100% sure which one matches up, so let's look. Well, HS has to match with MN. So if I'm going to check for the scale factor, HS over MN. And by the way, since these are similar, all of these ratios that I set up should be equal. So what about TS? Well, TS has to match with UN. And since I don't have any side lengths here, I'm not going to set up a third ratio. But let's plug in the information. We know what HS is equal to. HS is 20. MN is 25. And let's plug in TS. TS is 32. And UN, ooh, did I write that correct? UN? Yeah, notice we don't know that side. So, can I find my scale factor from this ratio? No, because we don't have enough, which means I have to use the ratio that I know. So if I want to find the scale factor, we're just going to reduce the ratio of 20 over 25. Well, they're each divisible by 5, so that's going to be 4/5. There's my scale factor. Now, could I use that ratio to find this missing side? Yeah, if I called this x, then I would take the 32 over x, and I could set it to 20 over 25 because that's equivalent to 4/5, but instead of doing it cross multiplying here, that's a big number. I want to set it equal to 4/5, and then I can cross multiply. And that's going to give me 4x is equal to 32 times 5, that's 160. And if I divide both sides by 4, and I could find this missing side. Even though they didn't ask me to, I really just needed to stop right there. That's how we use the scale factor. All right, so hopefully that gives you a little more confidence going into what we've learned and using it to what we're going to do today. All right, I do not want you to write this proof, okay? This is just a good one for us to look at. And we're going to do like 3 proofs today, so we don't have to write everyone down. But here's my goal. Prove the triangles are similar. Now, notice the first question is, do you see both triangles? Because that's a skill in its own right. You have 2 triangles here. You've got the small one, and then you've got the larger one. There we go. All right, so I need to prove that the small triangle is similar to the big one. Well, the only way we know how to do that is using angle-angle. So let's start off. What do they have? Well, what do we always start off with in a proof? Givens, right? What's given? And this is the part that a lot of kids skip or they don't write down, so be very cautious. You have 3 given pieces of information. You know the size of angle A, you know the size of angle AEB. Notice I didn't say angle E, because if I just say angle E, is that this angle down here? Is it the 50 degree? Or is it the big angle? So you have to be specific. But if I say angle C, you know what angle C is. I could have called this just angle C and that would have worked. Just like I could call this angle A and it worked. So I have 3 pieces of given information. You have to write that down. Now, what else do I know? Well, I know that the yellow one is a triangle. And I know that angle A, the yellow triangle, is the same angle A as the green triangle. So angle A is congruent to angle A by the reflexive property. Then I actually can find out. Now, I'll explain my reasoning here on this next step, but why did I know that angle ABE? Why did I know that this angle was 52 degrees? It's not because these are parallel lines. We don't know that yet. We could prove it, but we don't. It's the triangle sum theorem. If I add up these 2 pieces and subtract from 180, I'll get 52 degrees. So that's a triangle sum theorem. Well, now, if angle ABE is 52 and angle C is 52, aren't those congruent? We have a special property that we're not really going to use often. It's called the transitive property. And here's what it is. It's basically saying, hey, angle ACD is 52 degrees and angle ABE is 52 degrees. So if they're both equal to 52 degrees, aren't they equal then to themselves? So both angles equal 52 degrees. I'm okay, instead of using that fancy transitive property, if you just say both angles equal 52, then you know that those two angles are congruent. All right, what did we just find? We know one angle, one pair of corresponding angles are congruent in another pair, so we're done. Triangle ABE, the yellow one, is similar to ACD by angle angle. So notice we just have to prove we had two pairs of congruent angles. All right, let's write this one together. So I'll give you a second, draw the picture, write the statement in reason, and then I want you to fill in the given. And if you feel like you can do this proof on your own right now, go ahead. Okay. So let's start with the given information. Well, the only thing that the picture tells us is that we have we have a pair of lines that are parallel. So SR is parallel to UT. Weird looking U. UT. All right. Now, think of going through our proofs. All we know right now is angle, angle. So it doesn't matter the order that you do the next steps in. I like to use the given information. I like to use that to make a statement. So notice these lines are parallel. Well, my reason is going to be something to do with parallel lines. So what do I know if lines are parallel? Go back to your can figure it days. When we have parallel lines, you can pick one of the transversals. I'm going to pick this one, but you could pick the other one. And what does that make? It makes a Z. When you have a Z, whoa, that's the wrong thing. When you have a Z, alternate interior angles are congruent. So angle S, and I'm okay to call this angle S, is congruent to angle U. And my reason? Alternate interior angles. And our reason, if the lines weren't parallel, we wouldn't be able to use that. Now, that's one pair of angles. Cool, we're halfway done. I need to find another pair. You could do angle R congruent to angle T, and you could actually put it right in the same statement. And maybe I'll do that. Make this nice and quick. Since it's going to be the same reason, it's just the other direction, alternate interior, angle R congruent to angle T. And there's my second pair of angles. I have angle, angle, and I'm done. I just got to state that the triangles are similar. Now you do have to follow the correct order. So S to V, or you can start anywhere. If I start at S though, triangle S, let's see, S and U match up. And then if I go S to V, U would also have to go to V. And then V would go to R, and V would go to T. That would follow the correct mapping. And that's the angle-angle similarity, and we're done. It was really one given step and then two pairs of alternate interior angles. However, you could also do one other option here. Maybe you took that route. Did anybody say, ooh, I've got a bow tie? And you have vertical angles. So in this case, you would have to be specific and say SVR is congruent to UVT. So you have, and then that would be vertical angles, and that would be another pair. But we know we only have to do two, so this is the route I think I would take. All right, that's angle. It's pretty quick. A lot of times you see vertical angles, and a lot of times you see either alternate interior or consecutive interior angles that you would use to prove angles are congruent. Okay, what about the next theorem? Now, this is where it's up to you. I would title it side, side, side similarity. And if you want to write the blue sentence, you can, but I definitely would draw the picture and the information here. These, somebody just asked if these notes are on Schoology. That's what I kind of mentioned before. For some odd reason, I I don't know if it was the way I created this specific slide. I'm not guaranteed that these notes are going to be posted because I tried to post the blank slide earlier and it didn't work. That's why I am recording this video. So then when it's done, you'll be able to go through this and just kind of it'll be a YouTube video that you can fast forward through and get anything that you missed. Um, I'm gonna try to post these notes at the end of the hour, but Miss Hires said she couldn't, and we share the same slide. So I don't know why it decided to do that today, but it did. All right, so what is side, side, side? This is really important. We have to compare the three sides of one triangle to the corresponding three sides of the other. And it says if the corresponding side lengths of two triangles are proportional. So remember, when we say proportional, we have to set up this ratio. And if they all have the same scale factor, then we can conclude that the triangles are similar. So this theorem is basically saying you don't need to know anything about the angles if all three side lengths are proportional. Corresponding sides are proportional. So I'm going to use my highlighter to kind of set this up just to help you out. And here's a pro tip down here. To find the ratio, we're going to compare one triangle to the next. And it's easiest to do it with the longest side to the longest side, and then the middle side to the middle side, shortest side to shortest side. So here's what we mean. And it doesn't really matter the order you go in, but what if I take the shortest side of this triangle right here? Clearly that's the shortest side. So BC has to compare with the shortest side of the other triangle. So short side to short side. All right, and then what if I compare the middle side? So the middle side length is AB, and that has to be compared to the middle side length of the other triangle, which is EF. And that leaves the long side AC to match with the long side of DF. So it works best if you compare long to long, middle to middle, and short to short. And that's the only way that all these ratios are going to be compared. So if these scale factors are all the same, which in our proof we will have to check, then our conclusion is the triangles are similar. So notice how I wrote triangle ABC. That was all the lengths that were in the numerator of our ratios. And then the lengths from the triangle FED, the smaller triangle, those were all in the denominator. You can't mix these around. If I say BC, that means I'm starting with the big triangle and I'm comparing it to the small. So you always have to put the lengths from this triangle in the numerator and the lengths from the other triangle in the denominator. Make sure you're conscious of that. All right, this proof can be tricky, and it's the reason why it's tricky is students always assume too much when they're writing the proof. Right? A proof is a logical argument that has to follow a step-by-step process, and you can't just skip steps assuming that the person reading it is going to fill in those blanks for you. Okay. If that wasn't enough time, let me know. You could just do a quick screenshot of this if you need. Otherwise, if we have time at the end of the hour, I can always come back to some of these proofs. All right, let's do a side-side-side similarity proof. And just keep in mind, this is the three ratios we have to set up. So I'll give you a second I'll make this bigger for now, just so you guys can see it. But go ahead and draw these two triangles and label the sides. There's a reason why they're colored the way they are. You don't have to do that, but you might see why they're colored the way they are. And do not fill in the givens yet. There's actually a special way that I want you to fill in the given information. And if you do it that way, it really helps the proof just take form. So. All right, so how do we want to do our given information? Because I have three given pieces for each triangle, and I want to write that in the order that's going to make the most sense. Now, it doesn't matter if you start with the small to small, big to big, medium to medium. You can start with whichever one. I'm going to start with triangle ABC, and I'm going to start with the small side. And here's what I have to state for that given. I have to say, well, what is given? It's given that the length AB is 8. And then I'm going to go to the medium. So that's given that BC is equal to 12. And then I'm going to start with the other triangle, and AC is equal to 16. So that's given information there. But we have a whole other triangle. And I have to map the same order. Now, since I started with the small, let's start with the small one here. And DE is equal to 6. And then the next medium length is 9, so that's EF. And I should be conscious of how I wrote that. See how A goes to B, and then I went from B to C. So that's kind of the red to the green. So then I went from D to E, and the red to the green is E to F. So I should write E and then F, just to get my ordering correct with the letters. And then I chose to go from A to C, so that was kind of going red, blue, green. So I want to go D is the red, blue, green. So D to F. And that is also given. So since I put it in the same line, that's good. Now, why is that important? If I write it the way I did, look at what I just did. I wrote the small side over the small side, the medium over the medium, and the large over the large. I already have my ratios set up. So what I need to do then is I need to basically say, okay, if these are true, what has to be true? We need to set up our ratio. I need to compare AB, the small side, to the small side. So AB over DE. Actually, I'm going to do that in red. Sorry. I want to compare AB over DE. And that ratio has to be the same as the medium side to the medium side. And then that ratio, those two ratios, also have to be the same as the large side to the large side. AC to DF. Now, what's the reason that I'm allowed to compare side lengths? What's the reason that I'm allowed to set this up? Well, what did I just do? I compared the ratio, or ratios are fractions, of corresponding sides. And this step is one of the most missed steps that students skip. Right? So make sure you're comparing the side lengths and writing them out in words. We didn't compare numbers yet. Right? This is the logical step that we have to follow. So now the logic says the next step is going to be taking all that information that we know and just substituting in, well, what is AB? What is DE? So here's the benefit. AB is 8. DE is 6. See how I already compared small side to small side? And it's basically set up in my given information. That's why I wanted to write it specifically. So BC is 12 over EF is 9. And then AC is 16. That's the big side to the big side. So small to small, medium to medium, big to big. All right, well, in math, what allows me to take a distance AB and replace it with something it's equal to? That's called substitution. When you replace something with equal value. All right, well, now, what are we getting at? If these are truly similar, all three of these ratios have to have the same scale factor, right? So I'm just going to reduce the fraction to find that scale factor. What is 8 divided by 6 reduced down to? And that's where you just divide by 2. What is 12 divided by 9? Well, divide by 3 and divide by 3. Notice those scale factors are starting to match. And then 16 divided by 12, divide by 4, divide by 4. Since 4/3 is equal to 4/3 is equal to 4/3, that is basically, we don't really write side, 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 but there's my side, side, side. They're all the same ratio, which means we just proved that the triangles are similar. So it doesn't matter which one you start with, but I'm going to call it ABC. So if I match up ABC, then I just have to figure out, well, what matched with A? That's the angle between the red and the blue, which is angle D. And then to go from A to B, well, B is the red to green, so I got to go red to green, that's E. And then F. And the side, side, side similarity. All right, it's a little tricky, just getting used to how this is set up. But anytime you have 3 side lengths, do the exact same process. list the givens, set up the ratio, compare small to small, medium to medium, big to big, call that ratio of corresponding sides. So we write it in words first, and then we substitute, and then you reduce. Now, what would happen if, let's say that this ended up being, I'm going to erase this, but don't write this. I'm going to change it back. But what if this ended up being a 7? Ooh, that's not cool. Okay. What if this ended up being a 7? Does side, side, side work? No, because the scale factors are not all the same. So if one of them is off, then we would say these are not similar and we couldn't finish the proof. Okay. Now, I'm going to put that back to normal. There we go. So since they are all equal, side, side, side works. All right. How do we use side, side, side to solve? Well, this is where you get to make a choice here. I am going to have you write this one down. Okay, so let's take a look at this, and I'm going to hopefully give you a couple pointers right away. So we've got 3 sides on the small triangle. One of them is an algebra problem, or an expression, and we've got 3 sides on the other, and the other one has an expression. What I would do first is see how it's 3 times x plus 1. Let's just distribute that so it doesn't look so crazy. And I'm going to refer to df as 3x plus 3, because then I don't have to worry about distributing later on. So what has to be true? Well, we want to find the value of x that makes these 2 triangles similar. Well, what I would do is let's start off with our statement. What has to be true? AB is the small side of this triangle. So I'm going to match small to small. AB is going to be compared to DE. And that ratio has to be the same as BC, which is the medium length, compared to the medium length of the other triangle, which is EF. And then that has to be compared to the long length AC over the longest length DF. This ratio has to be true, or this proportionality statement. It has to be true if these triangles are similar. So now you get to pick which ones do you want to use. Well, we know A, B, and DE, so I'm going to plug that in right away. That's 4 over 12. And then I know BC. BC is x minus 1, and EF is 18. Wait a minute. Can I solve for x right here? Yeah, this looks much friendlier than using any of these 2 side lengths. I really don't even need to use this to find x. All I need to do is take my proportion statement and cross multiply. All right, let's see. So 4 times 18 has to equal, if I cross multiply the other way, 12 times x minus 1. And then we can just multiply. Let's see, 4 times 10 is 40, 4 times 8 is 32, 40 plus 32 is 72. So 4 times 18 is 72. Distribute the 12. And now it's a 2-step algebra problem. Add 12 over to the other side. Get 84. Divide by 12. Hold on one second. Okay, so then just divide both sides by 12. don't even have to show that work. And we get x equals 7. Okay, now they just said solve for x, we're done. If they said find the side lengths, then you just plug 7 in. You get 7 minus 1 is 6. And then you can plug it in anywhere, but 7 plus 1 is 8. 8 times 3 would be 24. If you want to know if that all this is right, then just check. Does 4 over 12, 6 over 18, and 8 over 24 all reduce down and give you the same scale factor? All right, one last proof and one last method. So side, side, side was this proof right here. What about side, angle, side? It's very, very similar. I don't know if you want to write down all of this, but I definitely want you to write the picture and the if-then statement down here. All right, I need to know that in side, angle, side, I have one pair of congruent angles, and that's what we have here. So in your proof, you have to prove that you have one pair of congruent angles. And then you have to prove the side lengths containing them. So let's say this is the small side of this triangle is compared to the small side of this triangle. So I'm going to compare small side over small side, and that ratio has to equal the big side or the longer side to the longer side. And notice it's the angle in between them. So I'm not doing anything with the side length across from this angle. If these two ratios are the same and the angles are the same, that's enough for us to conclude the triangles are similar. So some students kind of think of this as like a blend between angle, angle, and side, side, side. In this case, we just have two pairs of sides we're comparing and the angle in between them. All right. Sorry, I have a student in our waiting room that every time I admit them, it kicks them back out. All right, last proof. Let's write this one down. I'll give you a second to draw the picture. And I hope as you're drawing it, you're thinking, okay, I can't use side, side, side because I don't have all three sides. Can I use angle, angle, or do I have to use side, angle, side? All right. Now, as we're trying to prove triangles are similar here, our goal is to first write all the givens. And that's also a step. You can't skip steps here, right? A proof is a logical argument. If you skip a step, that means there's a hole in your argument, and we can't have that. So my goal is also to write the given information in an order that's going to be helpful with how I can use it in my proof. So here's what I'll do. Let's take the triangle on the left, and let's do the small side first. So DE, so that'll be my given, DE is equal to 9. And then I'm going to take the larger side, which is AE, and that's equal to 18. So I dealt with the triangle on the left first. Now let's go to the other side. And the only way that it's going to match up is if I match small side to small side. So BE is 15. Notice how that's kind of like a ratio. And that has to be compared to the larger side or the longer side, CE. Okay, so what do we do next? This is the tricky part. I only have two sides. Yes, I have a bow tie, and I've got vertical angles. If you want, you could state vertical angles right away. But I'd like to just use the given information to write my statement. And what am I going to do? I'm going to compare the side lengths in words first. Right? What has to be true? Well, the small side DE over BE, that ratio has to be the exact same thing as AE over CE. All right, well, why were we allowed to do that? We set up ratios of corresponding sides. So when sides go together, small to small, big to big, that's called ratio of corresponding sides. That's key because now that I have it written out in words, we can just substitute it right in. Well, what is DE? DE is 9. What is BE? BE is 15. And that ratio has to be the same as AE, which is 18, over CE, which is 30. And what allowed me to just plug in DE equals 9? Substitution. Right? Just replace something of equal value. All right, now, this is where we check the scale factor. We're going to divide 9 over 15. Well, they're both divisible by 3. 18 over 30. They're both divisible by 6. All I did was reduce, but that's key right there. Same scale factor, that basically tells me I've got a side and a side, right? Well, now all I need to do is prove that the angle between them is congruent, and that's where we can go with the bow tie. Now I have to be careful because I can't say angle E. I have to use the correct order. Angle AED. Now angles are always congruent when we write these, so use your congruent symbol, CEB. So there's my two sides and the angle that's right in between them. Now, the nice thing about naming the vertical angles is I can use that same order for the triangles. And my reason that they're congruent, side, angle, side. It's a weird looking A. All right, so notice how it's very similar to side, side, side. The only difference is we compared two sides instead of all three. And the reason why we couldn't do side, side, side is because we don't know the other two sides. The reason why we couldn't do angle, angle is because these lines aren't parallel. So I couldn't figure out angle A or angle D and how that relates to B and C. So the only option is side, side, side. All right, that's a lot. It takes some while to get used to. On Monday next week, Monday or Tuesday, whenever I see you, you will be doing Can Figure It with this, and we're going to be walking you through it together because setting up the ratio of sides is kind of tricky. Okay. You don't have to write this down. This is just a quick little review. If you want to take a screenshot of this, this might be helpful. But what did we do? Today we learned angle angle postulate, side 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 theorem, and side angle side theorem, all for similarity. So here are some hints. If you use angle angle, you have to show you have two pairs of corresponding angles are congruent. If you use side side side, you have to show all three ratios of corresponding sides are equal, meaning they all have the same scale factor. And then side angle side, you have to show you have a pair of included angles that are congruent, and then the both ratios of corresponding sides are congruent. So that's just a quick little overview of what we did today. And then the homework tonight. So this is the part that you have two sections. They're both from your textbook. And remember, these are on the there's PDFs. This is from chapter 6. So you have to look at 6.4. You're going to do 1 through 10, 16, and 32. And then 6.5, you've got 5 problems. For number 8 and 11, we're going to ask that you do 2-column proofs for that. So the directions, it's on the next slide. The directions are different. We're going to ask that all you do is just do a 2-column proof for 8 and 11. And remember, if the ratios aren't equal, then you could potentially, you can set up a proof, but then you're not able to solve it, and that can happen. My workout solutions are posted on Schoology, so when you're done, go to the homework section in Schoology, the homework answers, and check your work, and just compare and make sure that everything looks well, looks perfect.